In this tutorial, we will be learning on binary integer linear programming. We will be doing the coding in Google Colab. Like we did in the previous video, we will be starting with installation of Blueqat. Type the code !pip install Blueqat in order to install Blueqat. Let us do it in Google Colab. Type the code that was shown earlier and click on the play button to run the code. Blueqat will be installed after a while. Binary integer linear programming is to find out maximum number of binary qubits, that is vector x, and satisfy the constraint sx equals b, and maximize c times x. With the constraint for vector x, finding vector x, which maximize c times x, this is called binary integer linear programming. Let us create the final QUBO matrix. For that, we create the first term as a constraint which satisfy sx equals b equation. And this time, we try to solve this constraint by using matrix A, and solve this equation. We can remove the constant term, and we just have to calculate this equation. Let us do it in Google Colab. Type the codes. First, we install Blueqat, then import blueqat.opt as wildcat. Then import numpy followed by assigning a variable a which equals to wildcat and optimization. Then, we type the matrix A followed by constraint variable b, then assign variable a with QUBO which equals to numpy of zeros in 3x3 matrix. Next, we create a for loop of variable I which is in range of length of the constraint variable b. Then, we calculate the equation that we have seen earlier, and then, print the equation. Now once we check the constraint, we type the code, we get matrix of 1x3 which contains 1, 0, 0. In another checking of constraint, we get matrix of 1x3 which contains 0, 1, 1. We got two output constraint matrix that are 1, 0, 0 and 0, 1, 1, while checking on Google Colab. Let us now prepare the second term in Google Colab. In this, we create a new matrix which equals to numpy with diagonal matrix of 1x3, and print the matrix. Finally, we will create the final QUBO, by adding the first and second terms as matrix. Then, assign a variable b as 1, and then, calculate the equation of QUBO which equals to the variable b with the second term matrix. Then, we check the constraint matrix. Finally, we get the QUBO matrix as 1x3, that is, 0, 1, 1. Let us check the time evolution of cost function. This is a graph which represents the time evolution of the cost function. Finally, let us solve an example, when x1, x2 and x3 satisfy this equation. And find out the combination to maximize x1, x2 and x3 of the equation. Let us do it in Google Colab. Type the codes. First, we need to install Blueqat. Then we need to import optimization as OPT from Blueqat, followed by importing variational quantum eigensolver as VQE from Blueqat. Now we assign a variable e, it equals to opt.optm which is making the QUBO matrix directly from the equation. Then, convert the variable e to Pauli operator on QAOA. And decide the step which depends on the difficulty of the problem. We can get the result of the Pauli operator on QAOA with VQE. Lastly, we print the output containing 5 most common result. After running this program, we get 5 most common result, as we can see the output. We have 0, 1, 1 as the best answer. We can say that x1 is 0, x2 is 1, x3 is 1, is the best answer to solve binary integer linear programming. Thank you for watching this video.